everyone, welcome to this video. In this video we are solving the question of December 2014 consisting of 4.75 marks, that is it may have multiple correct options. So for solving any question from calculus of variation, the first thing that is required is to classify what kind of problem it belongs to. In this question you are given this extremal, this functional, and you need to find the extremal to this functional satisfying these boundary conditions, and in addition to these boundary conditions you have one extra condition given to you. This is known as subsidiary condition. So for that we have the Euler's equation modified in this form. Suppose if this is f and this is g, then our equation becomes f, the partial derivative of f with respect to y minus d dx partial derivative of f with respect to y dash plus lambda times the partial derivative of g with respect to y minus d dx partial derivative of g with respect to y dash is equivalent to 0. Here lambda is known as Lagrange's constants and which has to be determined using the given extra condition, subsidiary condition, this one, right. So let us get started. Our f is y dash square, so f of y would be 0 because it is independent of y, minus d dx of fy dash would be 2y dash plus lambda times what is g of y, our g is y square, so g of y would be 2y minus d dx of gy dash would be 0 because it is independent of y dash, so it is equivalent to 0. So here we have minus 2y double dash plus 2 lambda y is equivalent to 0, or we can write y double dash minus y is equivalent to 0. So let us solve this equation. We have solved this many times. So on solving this second order ordinary differential equation, we obtain y is equal to c1 e to the power square root of lambda x, sorry here we have lambda also, right, plus c2 e to the power minus square root of lambda x, because if you write this equation in operator form you get d square minus lambda is equal to 0 and you have d is equal to plus minus square root of lambda. So this is the extremal, right. Now we have to calculate these the value of these constants c1, c2 and lambda from the given conditions. So firstly let us substitute y of 0 is equal to 0. So we have 0, in place of y you will write 0, c1 e to the power 0 plus c2 e to the power 0. So you will basically get c2 is equal to minus c1. This is one condition. So ultimately your y reduces to y is equal to c1 times e to the power lambda x minus e to the power minus lambda x, or you can write y is equal to c1 sine square root of sine x, right. Into 2. So let us apply another condition. Other condition is y of pi is equal to 0. So you have 0 is equal to 2 c1 sine square root of lambda into pi. So clearly you can see that our extremal, the solution y, is of the form sine of something x, right. So these cannot be the options. So you are left with option A and B. Let us see which among these or both are the solution. So on applying this boundary condition we obtain this. So either c1 is 0 or sine of square root of lambda pi is equivalent to 0. Obviously from here you have lambda is equal to 1 or 4 or so on, but from here you can see that our lambda is 1, so lambda is fixed. Now let us calculate c1 using the given subsidiary condition. So what is the condition given to us? Let us see. the condition is you have integration from 0 to pi y square x dx is equivalent to 1, right. So, let us solve this. Substitute the value of y over here. What is y? It would be 2 c1 sine of square root of lambda x whole square dx is equal to 1. So, you have 4 c1 square 0 integration from 0 to pi sine square root of lambda x dx is equivalent to 1. So, let us just integrate it. So, you could write it as 1 minus cos 2 square root of lambda x divided by 2 into dx is equivalent to 1. Integrate this, separate the terms and integrate. So, we will get 4 c1 square, 1 by 2 integration would be x by 2 minus cos integration of cos would be sine 2 square root of lambda x divided by 4 lambda, 4 square root of lambda, and the limits are from 0 to pi is equivalent to 1. Just solve this, you will get c1 square is equal to 1 upon pi, and hence you will get c1 is equal to plus minus 1 upon square root of 2 pi. Hence, our y becomes 2, what is c1? c1 is plus minus 1 upon square root of 2 pi, right, sine lambda x, or we get square root of 2 upon pi plus minus sine of square root of lambda into x. So, let us see our options. So, obviously option A and option B both are the correct options. Hope you like this video. If you have any suggestions or comments, please do write in our comment box. Please share and subscribe this video. Thanks.